This video is a short summary of how capacitors in DC circuit works. It will briefly cover what a capacitor is, how they work, how they behave while charging, a brief look into the theory behind them, and a few real-life examples of capacitors. Firstly, what is a capacitor? The main function is to store energy in the form of charge, which creates a potential difference across the plates it contains. The plates of the capacitor are made of conductive materials, that is, metals, and are separated by an air or another insulator, which forms a layer referred to as the dielectric. It is due to this layer that current cannot pass through the capacitor, and it is able to store charge across its plates. When a DC voltage is applied to an RC circuit, positive charge accumulates on one plate and negative on the other. For every additional positive charge that arrives at the plate, one charge of the same sign must depart from that plate. This causes the plate to remain at neutral charge while also maintaining a potential difference. Eventually, after a certain amount of time, the capacitor will reach steady state condition, which is when the current ceases movement in the circuit. Before steady state is achieved, the current flows through the capacitor, slowing as it stores charge. Upon stopping, steady state has been achieved, meaning the capacitor is fully charged and equal to the source voltage. This graph shows how a capacitor stores charge and discharges it over time. As you can see, the red line represents charging phase, while the blue line represents discharging. Initially, the capacitor charges quite rapidly, and as time goes on, the process slows as it gets nearer to steady state. The process is the same for discharge, as it is initially rapid and then slows as it approaches steady state. As seen in the graph, steady state is achieved after approximately 5 time constants. These time constants can be easily measured by multiplying the resistance in the circuit by the capacitance. The equation that gives how much voltage is stored in the capacitor is given by E outside of 1 minus the exponential of negative t on RC, and the current is given by E over R by the exponential of negative t on RC. For discharge, the voltage is E times the exponential of negative t on RC, and current is given by negative E over R by the exponential of negative t on RC. Some devices that use capacitors include computers, which use them to supply the device with the correct power it needs. They can also be used in electric guitars, commonly used for its tone control. These were just 2 examples of capacitors used in electronics, as they are used in almost all electronics in some form. That concludes this video. Thank you for watching. I hope it helped your understanding with the fundamentals of capacitors.